In this lesson, Lesson 1-2, Part 2, your learning target is finding the x-intercepts, y-intercepts, and zeros of a function using a graph and algebraically. The x-intercept is a point or points where the graph meets the x-axis. The x-intercept always has a y value of 0. If you look at the picture on the left, the x-intercepts are where the graph or the curve is crossing the x-axis, which is the horizontal axis. At each of these points, because it's crossing the x-axis, your y-coordinate or y value is 0. The y-intercept is a point where the graph meets the y-axis. That y-intercept always has an x value of 0. There can only be one y-intercept. You can only cross the y-axis once. You can cross the x-axis several times, but can only cross the y-axis once. Therefore, there is only one point where the graph crosses the y-axis, and in this case, that point has an x value of 0. The x value is always 0 on the y-axis, because you just go from the origin straight down or straight up, in this case straight down, to figure out what the ordered pair or the y-intercept is. Looking at an example, we are going to use the graph of the function f of x equals x squared minus 4x plus 4 to approximate its y-intercept. Then we are going to find the y-intercept algebraically. Looking at the graph, the y-axis is, where the graph crosses the y-axis is the y-intercept. This curve or parabola crosses the y-axis right here. Now, if the origin is right here, then the y-intercept is 1, 2, 3 at y equals 4. So our y-intercept is at y equals 4. Now, they also want us to find the y-intercept algebraically. To do that, we are going to use the equation they gave us and substitute 0 for x. If I find f of 0, I'm substituting 0 for x because this point where the graph crosses the y-axis is the ordered pair 0, 4, right there. And since x is 0 for any point on the y-axis here, I will find the y value that is paired with an x value of 0 when I want to find my y-intercept algebraically. So substituting in 0 for x, I would get 0 squared minus 4 times 0 plus 4. I'm just evaluating the function they gave us for x equals 0. Simplifying my work, 0 squared is 0, minus 4 times 0 is 0, and then I would add 4 on the end. 0 minus 0 plus 4 is equal to 4, thus proving that us finding the y-intercept from the graph was correct. Our algebraic solution of f of 0 equals 4 is the same as y equals 4 on the graph. Looking at another example to find a y-intercept, we are going to use the graph of the function g of x equals the absolute value of x plus 2 minus 3. To approximate its y-intercept, we are going to use the graph. So looking on the graph, we are going to indicate where the graph crosses the y-axis, which is right at this point, which that point is 0, -1, which makes the y-intercept, or the y value where the graph crosses the y-axis, is -1. Okay, that is our approximation. They want us to also find the y-intercept algebraically? Well, to find the y-intercept algebraically, no matter where I'm at on the y-axis, the x value is always 0. No matter where I cross the y-axis, my x-coordinate is always going to be 0. So to find the y-intercept algebraically, I'm going to evaluate the function g for x equals 0. And if I do that, I'm going to get the absolute value of 0 plus 2 minus 3. If I simplify 0 plus 2, I get 2. So the absolute value of 2 minus 3 is really the same as 2 minus 3, because the absolute value just means the distance from 0, or to make the number positive. And 2 minus 3 is equal to negative 1. So our estimate or approximate value for our y-intercept was y equals negative 1. And finding our y-intercept algebraically was plugging in 0 for x, evaluating that function, and we also got negative 1. Thus, our answers matched here and here. We both got a y value of negative 1. So that is our solution. In this guided practice, I would like you to use the graph of the function to approximate its y-intercept and then find the y-intercept algebraically. At this point, I would like you to pause the video, solve the problem, and then join me again to go through the solution together. So now that you've done your work, we can look at the graph, and our y-intercept our graph crosses the y-axis at a y value of 1, 2. Okay, so I'm going to say my approximate answer is y equals 2. And I'm going to confirm that by finding the y-intercept algebraically. Okay, so this point right here, our y-intercept, or any y-intercept for that matter, has an x value of 0. Any point on the y-axis has an x value of 0. So I'm going to evaluate the function at x equals 0. And I get 0 to the 4th minus 3 times 0 squared plus 2. Okay, 0 to the 4th is just 0 times 0 times 0 times 0, which is 0. 0 squared times negative 3 is 0. And if I add a plus 2 on the end, 0 plus 0 plus 2 gives me f of 0 is equal to 2. So algebraically, we have found that our y-intercept is 2, as well as our approximate value that we looked at from the graph. So our answer here is going to be D. The next part of the video is going to look at finding the zeros of a function. Now, really, in my mind, zeros and x-intercepts are the same, but there's a slight distinction in their definition. So we're going to use the graph of f of x equals x cubed minus x to approximate its zeros, then find its zeros algebraically. Now, when we talk about x-intercepts, they're talking about the place where on the graph is crossing the x-axis. So I can easily, on this graph, look on the graph and find the 3 places, in this case, that our graph is crossing the x-axis. Remember, our x-axis is our horizontal axis, and so there's 3 spots where the graph hits the x-axis or crosses it. And those x values at those points are x equals negative 1, 0, and positive 1. Okay, here this is x equals negative 1, x equals 0 is at the origin, and x equals 1 just to the right of the origin. Now, that is the x-intercepts. The x-intercepts are found from the graph. the zeros, which are basically the same thing, the zeros are found by evaluating the function. Okay, so when we found the x-intercepts, or rather the y-intercepts, we plugged in 0 for x. When we want to find the x-intercepts, or the zeros of the function, we are looking for where y is equal to 0. Okay, all three of these points right here have a y-coordinate of 0. And I think we talked about in class the other day that y and f of x are the same thing. So when I want to find the x-intercepts, I'm going to plug in 0 for f of x and then solve for x. So I'm going to get 0 equals x cubed minus x, and I need to solve for x. Well, this isn't really very easy in this example, just because I have two values here, or two terms here with x, one with a power of 3 and one with a power of 1. So what I need to do is I need to factor this polynomial. So they have a common, both terms here have a common factor of x. So I'll factor out an x. And in parentheses, I'm still left with x to the second power. Right? I have one factor of x here and two factors of x here, which gave me 3 factors of x on top. And then I'm going to be left with a minus 1 here because this is only one factor of x, which I have already factored out in my polynomial. Now, x times x squared minus 1 is equal to 0. Since I am multiplying this factor times this factor and it's equal to 0, to solve for your solutions, you could say x equals 0 and x squared minus 1 equals 0. Because the only way, this is called the zero product rule, because the only way you can get a product, we're multiplying those two things, which means a product. The only way you can get a product equal to 0 is if one or both of your factors is equal to 0. So right away, by setting this factor equal to 0, we know one of our solutions is x equals 0. And if we set our other factor equal to 0 over here and solve that equation for x, so I'm going to say x squared equals 1 by adding 1 to both sides. And then I'm going to square root both sides of my equation. And when I square root both sides of an equation, I need plus or minus in front of my solution, because there's two numbers or two values that I can square and get positive 1. That would be a positive 1 and a negative 1. So plus or minus 1 really means, if I separate it out, positive 1 and negative 1. And then the x equals 0 right here comes from this factor of x that I factored out. So we've shown algebraically that we get x-intercepts, or zeros of 1, negative 1, and 0, and our x-intercepts are also 0, 1, and negative 1. In every example, your zeros and your x-intercepts are going to be the same. It's just definition-wise, they only refer to x-intercepts as being found on the graph, the place where the graph crosses the x-axis, and your zeros of your function are found algebraically by setting y equal to 0 in your function and then solving for x. In this example, I would like you to use the graph of f of x equals square root of x plus 4 minus 3 to approximate its zeros, and then find its zeros algebraically. Try this problem on your own and join me again in a minute when you have the solution, and we will go over the answer together. So in this example, if we're finding the zeros of the function, if we are going to approximate its zeros, they're really talking about the x-intercepts there. Okay? the x-intercept is where y equals 0 on the graph. I take that back. I circled the wrong point. Okay, the x-intercept looks to be over here. I was plotting a point on the y-intercept, not the x-intercept. So if I am looking at this graph, I have 1, 2, 3, 4. My estimate or approximation is that x equals 5. That's my x-intercept. Okay? If I want to confirm that, I'm going to find the zeros algebraically. 0 or zeros. My assumption here based on the graph is that we're only going to have 1 0 when I use the algebra to find the 0 on my own. So, here's the deal. F of x is equal to the square root of x plus 4 minus 3. Now, we are going to substitute 0 for y and solve for x. Okay, an x-intercept or a 0 is found by substituting 0 for y, which f of x is the same as saying y. So we're going to say 0 equals square root of x plus 4 and then minus 3. Now, to solve this equation for x, I'm going to first move the 3 to the other side. So I'm going to add 3 to both sides and say that 3 is equal to the square root of x plus 4. Now, to get rid of the radical or the square root, I'm going to square both sides. Square root and square cancel each other out. And I get 9 equals x plus 4. Well, if I solve this linear equation for x, I would subtract 4 on both sides. Subtracting 4 on both sides will leave me with 9 minus 4 on the left side, which is 5. And if I subtract 4 here, those cancel out, and I'm left with x. So I have confirmed that our x-intercept, or our 0, when we find it algebraically, is 5.